this is going to be some great revision for you here. The 10 hardest questions in P3. Sorry if I sound a bit croaky. I have a new menu at the moment, so I'm just about to sound a bit croaky throughout this. So these are the questions here. I've gone through and I've looked at exam papers and picked out which questions I think are the hardest. In the exam, you won't get them given to you like this. You'll probably get them broken down in a few sections. But if you can do these questions, you're doing really, really well. So there's 6 marks per question. That's the way I've decided to divide it up. 10 questions, so this should take you about an hour to do. There are a couple of ways you can do this. You can pause here and have a go at these questions, or you can just work through them all with me and see how you do. So you need to know about long-sightedness and short-sightedness, what causes them and how we can correct them. So in a normal eye, let me just quickly sketch that out for you. Normal eye here, this is the retina. And this here is the lens. The light comes in like this, and in a normal eye, it is going to be focused on the retina. However, when someone is short-sighted, the image is going to be focused in front, and when someone is long-sighted, the image is going to be focused behind, and we need to use glasses to correct that. So I'm going to do a bit of writing and get back to you shortly. So short-sightedness can be caused if the eyeball is too long or the lens is too powerful, and it can be corrected by a diverging lens because we need to bend the rays outward a bit to make them focus on the back of the retina. Long-sightedness, the eyeball is going to be too short or the lens can't focus for some reason. This could be a problem with the lens, or it could be a problem with the ciliary muscles or suspensory ligaments, and we need to bend the light out a bit. So for that we use a converging lens. Short-sighted people can only see near objects correctly, and long-sighted people can only see distant objects correctly. Quite a lot of questions they can ask about this. This is one that people tend to skip over. That's why it's quite a tricky question. So for this, I would give you 1 mark for each of these bits. 2 marks each for telling me how long a short-sightedness is called, and then 1 mark for working out which lens you need to use to correct it. So this could come up as a potential 6-mark question, describing how ultrasound can be used to give an image of a fetus. And I've already got a video on this, so I'm just going to paste in what I wrote on there. So ultrasound can look at the differences between the tissues. This is a really important thing when we're looking at fetuses. So we can tell the difference between bones and soft tissue because they have different densities. And when we cross between the boundary of one tissue to another, say this is our boundary here, this is our ultrasound, we're going to have partial refraction and partial reflection. And this wave here, this is the important one. This is the one that's going to go back to the ultrasound technician, and we're going to be able to tell how far away that boundary was, how far, if there's a second boundary and some more refraction takes place and then some more reflection takes place, we are going to be able to tell from the time it takes how long, how wide this boundary is, because waves travel at different speeds in different densities, and this is the equation you're going to want to use to work that out. So there are quite a few things here, but basically each sentence would be a mark. More than 6 marks here. I got this by looking at loads of different exams and bringing together everything that they wanted you to know across them. So if you manage to remember all of this and write all this down, you're doing really, really well. So this is probably the hardest type of ray diagram they can ask you to do, but all of the rules are exactly the same. I just want to point out that I can't use pencil and a ruler because I'm using an iPad and a stylus, but you have to when you do this. So the first line you need to draw is from the top of the object across to the lens, and because it's a diverging lens we need to go through this focal point here. So I'm just going to line this up. We need to draw the line going up there like that, and you'll notice that it is going to be backtracked through this focal point here. The second line we need to draw from the top goes from the top through the middle of the axis. I know I didn't go quite through the middle, and because this is the top here, that is going to be the top of our object there. I'm just going to switch to red for the second colour for the bottom, so to make it a bit easier. So again, I need to draw a line straight through, and I need to go through my focal point again. So just lining that up, and we'll have a line that looks like this. Track that back, and then I need to go from the bottom through the middle. And this here is going to be the bottom. So this is going to be my object here. Now I know this is a bit skew-if, but I've had to draw this freehand. You would of course have a pencil and a ruler to do, and that's it. That's going to be the hardest ray diagram they're going to ask you to draw, but all the rules are exactly the same. So I'm going to give you 1 mark for each line if you've got it. I'm going to give you 1 mark for picking the correct focal point, and then another mark for drawing your image. So this could come up as a potential 6-mark question describing how a transformer works. So we have our AC current going in here, and what this is going to do is induce a magnetic field around our iron core here. When this passes through the secondary coil, this is going to induce a potential difference or a voltage. I'll just write this up and get back to you in a second. So this is my answer here. You're going to get a mark for saying there are 2 coils of wire, and it's going to be around a primary coil. So the alternating current is put over the primary coil, which causes a magnetic field. The magnetic field passes over the secondary coil and induces, this is a key word here, an alternating potential difference in the secondary coil. In your exam, please write things out in full and don't use shorthand like I have. So there are going to be 2 equations we're going to be using for this. Vp over Vs equals Np over Ns, and that Vp times Ip is equal to Vs times Is. Quite a lot of maths going on. This is quite a tricky question because it involves you doing several things. So let's just go through the question and work out what we've got. So 35 turns on the primary coil. This is Np. Current of 17 amps. That is Ip. Secondary coil has 65 turns, so that is Ns. And a voltage of 200, so that is Vs. Find the current across the secondary coil and the voltage across the primary coil. So with the first equation, Vp over Vs equals Np over Ns. We have 3 of the 4 bits of information, so we can do this. voltage across the primary coil, VP over VS, which is 200, equals NP, which is 35 divided by 65. So we need to do a little bit of maths here and a little bit of rearranging here. I always like to do my maths before I do my rearranging. So 35 divided by 65 equals 0.54 times 200. So voltage across the primary coil is going to be 10, let's say that's 108 volts. I'm saying it's 108 volts because I'm giving my answers to the same number of decimal places that they gave it to in the question. So now I have my VP, I can work out the current across the secondary coil. So VP times IP equals VS times IS. VP equals 108 times 17 equals VS, which is 200, times IS, which is what we're looking for. So I'll just shift up here to rearrange that. So IS equals 108 times 17 divided by 200. Just plug those numbers, 108 times 17 divided by 200 equals 9.18 amps. So really quite a lot going on there. 1 mark for popping the numbers in the right place, 1 mark for the answer, 1 mark for the unit. Again, 1 mark for your working, 1 mark for your answer, and 1 mark for your unit. So this is maybe a slightly tricky question for you to do if I didn't give you a picture. In the exams they would probably give you a picture and it would look something like this, but you're going to have to look in the exam and just carefully think about the picture. Maybe get a different colour pen and try and trace out the probably 2 different circuits that we're going to have going on here. So the first thing you need to say, this is a key here, is that the key completes the first circuit. And as it completes the first circuit, it turns on so it allows the current to flow through. And as the current's flowing through, the electromagnet turns on. So we've got our key here. When the key is turned, it completes the circuit. This allows the flow of current. This is our electromagnet here, our coils going around an iron core. When the circuit's completed, the electromagnet is going to turn on, and it's going to have some effect on this second circuit, which is going to allow it to complete. So in the exam, so I've seen ones that have got a pivot here, or there might be a lever involved, and that's the sort of thing you'd have to say. Be really clear to the examiner so you know exactly what's going on. And then when the second circuit has completed, you're going to be allowing the starter motor to starter motor to run. So 6 basic points for you there. Remember, in this sort of question, you're going to need to pay attention to your quality of written communication. Just writing bullet points like I've done isn't good enough.
you're going to have to put this in full sentences. Make sure your spelling is correct, and that you have capital letters and commas in the right places. This is a question that really throws people. How can you be accelerating while going at a constant speed? So first of all, we need to know a few definitions. You need to know the meaning of speed, velocity and acceleration. So speed is just how fast you're going. Velocity is how fast you're going in a certain direction. I'm just going to underline that. And acceleration is a change in velocity. Now, most of the time when we talk about velocity, speed and acceleration, we're talking about it going in a straight line. Now remember, velocity is speed and direction. So if we talk about velocity going in a straight line, the only thing that can be changing is speed. But in a circular motion, we are talking about velocity going in a circle. So if again, the only two things that can be changing are speed and direction. Here it is not going in a straight line, because a straight line would be going this way. It is constantly changing direction. So even though the speed is the same, it's constantly changing direction because it is going around in a circle. Now there also, I split this question into 3 parts because the first part is a really hard question, but it's not a 6-mark question. So I just wanted you to list for me the 3 things that can affect centripetal force. So I'm going to talk about an increase in force, and that is going to be an increase in mass, an increase in speed, and a decrease in radius. Everyone always gets that last one confused. For an explanation about why it's a decrease in radius and more on this, I do have a long video on centripetal force which will explain it all. So on this one, I'm going to give you a mark each for getting 3 of these, and then I would like an explanation that velocity is how fast you're going in a certain direction, that you're constantly changing velocity when you're going around in a circle, so you are changing velocity. So this is about balanced moments, and whenever I see a wordy question like this, the first thing that I like to do is to draw myself a picture, just because this is the way that I like to learn. So this is the way that I like things to do. So this is Primrose here. She has a force of 18 newtons and there is a distance of 3 meters. This is Trigger, one of my other cats over here. He is a lot heavier than Primrose. Primrose is a tiny little thing. Trigger is built like a very stocky rugby player. And we need to find that distance there. So this is a complicated question because there are 2 things going on here and you need to rearrange an equation. So the equation that we need is moment equals force times distance. So this is distance here in meters, this is force in newtons, and this is moment in newton meters. So we have lots of numbers here. So the moment over this half of the equation, or this half of the seesaw here, is 18 times 3, which equals 54 newton meters, and because this seesaw is balanced, we know that the moment over this side is going to be equal to the moment over this side. So we use our same equation again, except we put our 54 in here. We have 35 as our force, and our distance is the bit that we don't know. So we need to rearrange this slightly. Divided by 35. So the distance equals 1.5 meters. Now this is a tricky question for a number of reasons. So I'm going to give you 1 mark for the equation, 1 mark for the working, 1 mark for the answer, 1 mark for the units. Now I've given you a mark for the equation over here and the units over here, so I'm not going to give you it again. I'm going to give you a mark for the working and a mark for the answer. So this is our hydraulic system, and here we have a small area, a large area, and they're connected together. So there are a few things the examiners like you to talk about for a hydraulic system. First of all, the inside is filled with liquid. And the reason it's filled with liquid is because liquid, and I love this word, is incompressible. I think I've spelled that correctly. Incompressible. It means if you try and squash it, there will be an equal pressure radiated in each direction. It's a bit like a balloon. If you try and squash a balloon, you can't really squash a balloon too much, so it will eventually pop. Now, the advantage of this is that you can take a small surface area, apply a small force, and that will be transmitted over to somewhere that has a large surface area as a large force. And this is really good for things like hydraulic jacks in cars and in stage mechanics. If you want to be really fancy, you can put the equation in there, but a written question like this generally won't require that. Now this question may not seem very hard because it's not, but it's a sort of question that people frequently overlook because it's not very hard, and because it's such a small part of the course, it might easily be something that your teacher did very quickly, or you didn't think was very important when you actually did it. So here is my irregular shaped object. I'm going to get a clamp stand and I'm going to clamp a metal rod on it. I'm going to get a bit of string which I'm going to attach a weight to, and this is going to be my plumb line. I'm going to make 2 holes in my irregular shaped object here, and then I'm going to attach my irregular shaped object onto the end of my steel rod. I'm going to let the plumb line and the irregular shaped object swing freely until they come to a rest, and when they do come to a rest, I'm going to draw a line using a ruler straight down. Now you're going to have to do this twice, and then where the 2 things cross, this is the centre of mass. You can check this by balancing on a pencil. If you said that you only do it with 1 hole, you're limiting yourself to a maximum of 3 marks there. So to get our marks, I'll be looking for the fact that we've got 2 holes. I'll be looking for a description of the setup. I'll be looking for a description of the plumb line and that you're letting it swing freely and come to a rest. I'll be looking for a description of the fact that I'm letting my irregular shaped object swing freely and come to a rest, and then using a ruler to follow the plumb line straight down and to draw a line, and that where they cross is going to be a centre of mass, and that I can check it by balancing on a pencil. They're not a very hard question to finish on, but one that quite frequently gets overlooked, and they do like asking questions about it. Well done if you got any of those right. Those are really, really hard questions. If I was taking this as class, this is how I'd mark it. This is very, very rough because they're all super hard questions. I'll generally throw some easy ones in there. Well done. Let me know how you did, or if you've got any problems with the answers, or if you want me to check any of your work. Thanks for watching. I really hope this is helpful. Subscribe so you don't miss any of my new videos. Share to help your friends get better grades. Any comments, corrections, questions or requests down below please.